Hello, my name is David Fish and I'm the project manager of the Altepetl Engineering team. I have the pleasure of introducing you to our Fall 2014 Civil Engineering 495 project overview, as well as our talented members. The objective of this project, as stated in the request for proposal, was to improve multimodal efficiency and safety for the Interstate 8 and Lake Murray Boulevard interchange and the adjacent roadways by designing and constructing roundabouts at each end of the bridge. It was also to reconfigure the geometry of the approaches and departures of the adjacent roadways. The Altepetl team prides itself on having one of the most experienced groups of individuals that one can find at this level. These individuals are Joshua Woodruff, our transportation engineer and resident CAD wizard, Michael Singley, who tackled the project's hydraulics and hydrology matters, David Fish, myself. Not only did I act as the project manager, I also took on all of the structural and geotechnical engineering needs of the project. Daniel Connor, he handled the scheduling and construction phasing of the project. Leonardo Flores provided the traffic analysis and determined the feasibility of our various alternatives. And Corey Sabota, he took on the environmental concerns introduced by the project. Now that you know a little bit about who we are, I'll let each one of these guys tell you about how they took on the different aspects of the project.
Hello, my name is Joshua Woodruff, the roadway design engineer and CAD specialist. The existing site shown here is located off Interstate 8 in La Mesa at the 70th Street, Lake Murray Boulevard exit. The site includes 3 intersections, 2 of which are signal controlled and 1 is stop controlled. The 70th Street Alvarado Road and the Lake Murray Boulevard Connecticut Avenue intersections are signal controlled. The stop controlled intersection is located on Parkway Drive at the I-8 West on-ramp off-ramp. There are no bicycle paths located on the site, and pedestrian crossings are long and unsafe. The existing traffic conditions that contributed to the geometric design will be discussed by the transportation engineer. As the roadway design engineer, I work directly with the transportation, structural, geotechnical, hydraulics, and environmental engineers to produce a fluid and appropriate geometric design. This design had to improve vehicle flow and pedestrian and bicycle safety to create a complete design. A couple designs were analyzed before the current design was used. A prior design entailed 4 roundabouts as shown in this picture. This design wasn't used because the site lacked enough space to design without major grading or the use of retaining walls. Another alternative design was having a diverging diamond interchange on the bridge between the 2 roundabouts. This is a schematic drawing of the design with the diverging diamond interchange. This design wasn't feasible due to the length of queue and the space needed between the roundabouts. To meet the needs of the current and projected vehicular traffic, a 2-lane, 180-foot inscribed circle diameter roundabout was created for the 70th Street, Alvarado Road, and Lake Murray Boulevard Parkway Drive intersections. The lanes inside the roundabout are 15 feet wide, and a WB-67 interstate semi-trailer was used as a design vehicle with a minimum design radius of 45 feet. A 10-foot concrete truck apron with a rolled curb was added to the island, the roundabout, to accommodate the sweep path of the design vehicle. The rolled curb was used to transition to the pavement to prevent the use of daily traffic. On the southern roundabout, designated right turn lanes were used to accommodate heavy traffic. The stop-controlled intersection on Parkway Drive was replaced with a signal-controlled intersection to improve traffic flow. Another priority for this site was to create pedestrian and cyclist safety. ADA accessible crosswalks with flashing markers were added to each roundabout. A new 8-foot, 2-way, green-painted bicycle path was added to the west side of the bridge. All lanes on the bridge are 11 feet wide and will be used to slow vehicles down and create a safer environment for the pedestrians and cyclists. To accommodate the size of the roundabouts, the Shell gas station and the truck and SUV center north of the northern roundabout will need to be purchased. Also, part of the Alvarado Parkway Institute parking lot will need to be purchased for the proposed Parkway Drive alignment.
My name is Leonardo Flores, the transportation engineer and traffic analyst for this project, and I'll be discussing our traffic analysis findings. In order to produce accurate results, our team of specialists performed traffic counts and lane measurements. The data gathered was used for the baseline volume movements and existing network conditions. Our projected results are based off Sandex regional traffic forecasting for the year 2035. As seen on the slide, the existing conditions demonstrated that the worst-case scenario was during the PM peak hour. Our calculations show an average LOS of D for the baseline volumes and an LOS of E for the predicted volumes. As far as queuing, PM peak continues to be the worst-case scenario with over 1,000 vehicle penalties for the baseline and projected volumes. The video being shown is a short simulation of the existing conditions during the worst-case scenario. As mentioned by Joshua Woodruff, several designs were tested in order to identify the most appropriate design. The chosen design consisted of the two roundabouts and a new signalized intersection. The design showed a significant improvement over the existing conditions. As seen on the slide, the proposed conditions demonstrated that the worst-case scenario was during the AM peak hour. Our calculations show an average LOS of B for the baseline volumes and an LOS of C for the projected volumes. As far as queuing, the PM peak becomes the worst-case scenario with 4 and 28 vehicle penalties for the baseline and projected volumes, respectively. The video being shown is a short simulation of the proposed conditions during the worst-case scenario, in which the positive results become apparent.
Meeting the project's objectives of increasing both multimodal efficiency and safety required a new overcrossing structure. There are several differences between these two structures as shown here in this comparison. The structural depth was reduced to 4 feet in order to maintain the existing deck elevations while meeting the AASHTO standard of 16.5 feet of vertical clearance. The new structure is a 4-span continuous pre-stressed cast-in-place box girder bridge as opposed to the steel girder simple span bridge that exists today. The new Lake Murray Boulevard and 70th Street overcrossing is 28 feet wider than its predecessor in order to meet the current and future traffic needs, as well as enable us to introduce full street concepts. As depicted here, the overcrossing will be constructed in 2 stages and have a 3-foot closure pour connecting the two. This staged approach will enable us to maintain traffic continuity during construction. CT Bridge and VBent software were both used to analyze the superstructure and bents respectively, enabling me to accurately determine and detail the reinforcement needs. As for the geotechnical analysis, we were able to find a log of test borings in a recent set of as-builts. The borings from the Mission Valley East Light Rail Transit project were taken from the same site as our project and therefore provided us the much needed information to classify and analyze the soil. This analysis led to these foundation recommendations, and since I am the structural engineer, I decided to use these recommendations with relatively little hesitation.
Hi, my name is Daniel Connor and I am the construction manager for Altepetl Engineering. Due to the vicinity encompassed by the project at hand, the ability to properly phase the construction process was vital to ensure all deadlines were met without delay. The project will span a 14-month duration at a cost of $17.2 million, with all costs being derived from the Caltrans B's numbers for District 8. The first phase of construction will span a 5-month duration and consist of the demolition and reconstruction of the western section of the Lake Murray Boulevard 70th Street Bridge, along with minor median replacements at the intersection of 70th Street and Alvarado Road. The second phase of construction will encompass the demolition and reconstruction of the eastern section of the bridge, this lasting a duration of 5 months. With the completion of the western section accomplished in Phase 1, traffic will be temporarily rerouted to this section to allow for a continuous flow throughout the construction process. Phase 3 will hold a duration of 2 months and will address sidewalk demolition and replacement activities in both the northern and southern intersections, as well as vegetation removal and grading required to effectively accommodate roundabout installation. Spanning 2 months, Phase 4 of construction will consist of the installation of both the northern and southern roundabouts, along with the construction of the center median that spans the Lake Murray Boulevard 70th Street Bridge. To further complement the activities outlined in both the demolition plan and traffic control plan, a water pollution control program was drafted to ensure that all stormwater pollutants caused by construction are properly monitored and contained throughout the project.
In considering hydrology and hydraulics management for this project, the increase in road surface area from the existing to the proposed condition is slightly less than 1 acre, which results in runoff increases to the 2-year, 10-year, and 100-year storm events. There are 8 drainage management areas or drainage basins identified to manage runoff, which will be considered over the course of the project. The basins drain to 5 points of compliance or POCs, where surface flow converges and becomes hydraulic flow in the storm drain system leading to the Alvarado Channel, which runs through the project site. One of these POCs was reduced in flow. 2 others will be increased only slightly and less than 10%, which is considered negligible, therefore flow mitigation is not necessary. Both of these POCs have adequate existing water quality treatment to meet Casco BMP standards. However, one storm drain pipe will have to be sized up from 0.9 meters to 48 inches to prevent pressurized pipe flow. The 2 remaining POCs exhibit an increase in flow of greater than 10%, and their runoff must be managed. The flow increase will be handled by the use of 2 extended detention basins. These basins are fed through weir boxes, which divert runoff flow in excess of the existing runoff into a basin, while allowing flow equal to or less than the existing amount into the storm drain system via an orifice in the weir structure. Water quality of these basins will be addressed through the use of a continuous deflective separation, or CDS units, sized to effectively clean water at or above the expected flow rate into the POC. Additionally, 2 curb inlets located in the northern intersection must be relocated since the curb in the proposed surface will be pushed back. The new location of these curb inlets will be accompanied with new piping to tie them into the existing storm drain system.
According to the California Environmental Quality Act, a mitigative negative declaration was required for this project. Some potential areas of concern associated with the project are air quality, greenhouse gases, noise, water quality, and transportation. With mitigation, the overall impacts of these areas will be considered less than significant. The project itself will be improving traffic efficiency and minimizing vehicle idling time, therefore significantly reducing most of the current environmental impacts. During demolition and construction is when the greatest impacts of the project will occur. To reduce these, many BMPs will be utilized to minimize these impacts as much as possible. There are currently 7 endangered and/or threatened species that are potentially present on the site, but due to current urbanization, the site is not a very suitable habitat for any of these species, therefore having no effect on them. Overall, the project will be more beneficial to the environment than the current conditions.
Well, that just about does it for us. I want to thank you for listening to our presentation and for a great semester.